Yeah, hi. Good morning. This is Suresh. See, in the previous class, so we covered about the Hibernate DO support. So how we can use the Hibernate DO support, we observed like using how we are going to use. So just simply we are trying to extend the Hibernate DO support to our the DOIMPL class. So what is our DOIMPL class? So it is an student Hibernate DOIMPL. So we are trying to extend that Hibernate DO support so we can eliminate these lines of code. Like we don't need to like define the dependency property, and we don't want to define any. It's like constructor injection or setter injection, right? So if you define any constructor setter injection, what's going to happen? So we need to define those information in configuration file so that the container can identify and is going to create an object for the dependence, right? So to eliminate these informations or the configuration, so what we did, so simply we extended our class, so Hibernate DO support, so that we are able to get the same functionality. So before what we use Hibernate template, right? Because the Spring provided Hibernate DO support. It's not it is not provided by the Hibernate. The Hibernate DO support is provided by the Spring framework. So if we are using the Spring Hibernate DO support, so directly we can integrate. So we can eliminate, we can remove some these lines of code. So directly we can reference to the session factory. The session factory is contain data source. So the data source can contain so some of the properties like what is the username and password URL. So these are the informations. So we can get it right. So now, so like today we are going to see one important concept called caching. So caching is nothing but like we have I'm trying to explain some example. So we have some Facebook application, right? At first time we are trying to log in our Facebook application using so username, password, like my first name, last name, username, password, and we are trying to give a submit button for instantly our username information, right? So once we save our information, and if you what is going to happen for next time if you log in into the application, so simply we are going to provide so username password. So once we provide the username password and we are trying to click on the submit button, right? So once we click on submit button, what's going to happen internally is going to use our Java code. So whatever it is, because if the Facebook application is developed in Java, so it's going to use our Java code. Like for example, some logins are late. So from logins are late, is going to hit with the database. Is going to hit with the database, right? So and is going to compare username password, and if it is working fine, so from the DB is going to show some different UI page like home page we can call it as, right? So now what I'm doing here, so where the cache exactly is going to work, I'm going to explain, right? So now again within the 5 to 10 minutes time you log it out. Again you're trying to log in into the same application, you're trying to log into the same application. So what is going to happen, what's going to happen here? So again the same process is going to happen, like it's going to interact with some login servlet, and from the login servlet is going to hit with the database. So again trying to get the information from the DB. So this is what happening. So just imagine not only one user, so there are the many users. So for example, we have 1,000 users are trying to connect with our Facebook application, and they are trying to just log in. So at a time, if the 1,000 requests are coming to the DB, at a time the 1,000 requests are coming to the database. So what is going to happen? So the DB performance is going to low, and so based on the database, the entire application is going to provide low performance. So for this purpose, so what is going to happen? For this purpose, so the cache is going to work. Where the cache is going to work, we will see. So this is our UI page. So this is our Java code, and between the Java code to the database, between the Java code to the database, between the Java code to the database, so the cache is going to work. So nothing but here the cache is going to work. Here the cache is going to work. So how the cache is going to work? So at first request, so in the cache we will define some methods. We will define some method and the parameter. So if the method is going to hit with the same parameter, the method is going to hit with the same parameters. At first time, within the cache, we don't have a data. At first time, is going to interact with the database, and it is going to get this information from the database. And one copy of objects are copied into the cache. One copy of object copied, and another copy is shown to the is transferred to the UI pages, so that so it's going to check with the username password, and if it is matched, then it's going to allow to the application. And at the second time, if they're trying to access same with the so same parameters, so then what is going to happen? It's not going to interact with database. So from the cache, the data is going to return. So this is what the cache is going to work. So I think now we got an idea how the cache is going to work, right? So for this purpose, we need to define some of the properties, because as I say, the cache is going to check with the method along with the same property parameters, not properties, parameters. If it is the same parameters, so then is return the object from the cache level. If anything, the parameter is different, again is going to interacting with database. So again, is trying to copy one object here. The another copy is going to return to the UI. So this is what the cache is going to work. So like the Spring can support number of caches frameworks. So what are the cache framework the Spring is going to support? We will see. Now we got an idea the how the cache is going to work. So the Spring supports Spring supports cache like EHCache and do Gigaspace, and JBoss cache, JGS, and EHCache. So these are the caches are supported by Spring frameworks. So why I'm explaining means we are interacting with like we are learning from Spring related concept. So that so we need to know the Spring how many cache framework is going to support. So these many frameworks the cache is going to like the Spring is going to support. Now so we are discussing EHCache. So if we discuss one cache framework, so remaining caches are the same configuration. So if some specific configurations are available, so that so we can get this specific configuration we can use. So if we learn one cache framework, so easily we can learn other cache frameworks also. It is not difficult to learn. So we are trying to learn EHCache. So how we can use? So before using the EHCache frameworks, now we want to know, so how we can like inform to the container, the Spring container. So these are the cache related configuration. So please like configure those cache information. So because the Spring framework entirely depends on the configuration, right? So now, so I'm trying to explain here. Here I created Spring cache framework. So now what we are trying to learn EHCache. We are trying to learn EHCache. So how it's going to work. So for our understanding, I created one separate configuration file for the cache related frameworks. So we need to specify cache here, like it is an EHCache. So and you can observe, so these information having some XSD file. So if you copy and paste, so it's going to show some existing information, like these are the, if you open any one, so it is an XSD file, and we can use this cache manager or annotation driven, what is the name, key generator, like we have tags we need to use, so those specified here, right? So now what I'm doing, for our understanding purpose, I'm trying to use mode. So like here, XSD attribute more, it's not getting. So element name, not attribute name. So we need to use element. Uh, so this is an existing element, annotation driven, and so this is another element called advice. So these are the complexity elements, and this is also complex type. So how many elements we can use? So we have only the two elements called annotation driven and advice. So these two information we can use. So remaining are inside the element, so we cannot use. So that's the reason we are unable to get. If you're trying to use, so remove and use H. So see, advice and annotation driven we are able to see here. So element type advanced context model caching. So this is the way we can use. So advice and config location. Sorry, annotation driven. Right. So and so if you say the advice is the error is gone. So so this is the way we can use. So that's the reason what I said. So we need to define some naming space here, so that the container can load the naming space and get the appropriate tags for our. So what are the tags we specified in our configuration? So those tags can get it from the namespace. So I use the Spring Cache 3.1 XST. So the 3.1 XST only we open. So these are our 3.1 caches, right? So in that we are able to use So annotation driven and advice. So this is the way we can define our configuration file and so inside the cache configuration file. So again, what I did here, EHCache.example. So for how many caches frameworks you are using in our application, so you can specify, you can like define the each XML file so that it is easy to understand and easy to add an element or remove an element. So we can easy to add or remove element from the specific configuration file, right? So we have a one main configuration file here. It is this is the main configuration file. So here also we can define, but so if you are defining here, so if you are trying to change any information, so we need to get where exactly we define our configuration information. So it's going to take some little bit time. So that's the reason what I suggest. So keep here the separate XML file or any configuration file so that if you want to change anything, so directly we can go the specific configuration file we can change, right? So this is the way we can use. So this is the EHCache file, and once we define the configuration, what I said, so we are trying to define EHCache.xml. So what it's going to contain? So EH is going to contain the specific information called. So how many element can store inside the cache, because cache, if you are increasing more element, so again we are going to get in some memory related issues. So we need to define, so before running our application, how many elements and what is the time period, and like, so what method is going to execute. So we have some properties, so we need to define inside the specific cache related file. So what I did here, so here it is an EHCache XML. So here I define. So this is the default cache and it is the custom cache I defined. So default cache is coming as a default cache tag, and custom cache is simply is having the cache. So if we observe default cache and so custom cache, internal values are the same, but only the tag is the different. So make sure if you are not writing anything, we need to define the default cache. And if you are defining your own cache, it's like custom cache. So the custom cache is going to execute. And if the custom cache is not available, if it is getting an error, so the default cache is going to execute. That's the reason. So we need to define two caches, one default, one custom. So you can define as many customs but one default cache is mandatory, right? So what is going to specify max elements in memory? So in the cache memory we can store up to 500 elements. So eternal means, so if we have some required information, so those informations are not arised from the cache, right? So for this, we can specify eternal true. And overflow to disk, what is going to specify? If the memory of the internal memory is full, so if you are trying to insert some of the elements, so example, so what I suggest here, like, so this is our cache. Here I suggested like 500 elements are inserted into the our cache. Again, one more request came, that is a new request. That is a new request. If the new request came, what is going to happen? It's going to interact with the database, and it's going to have some copy here, and one more copy is returned to the UI, right? So the copy is trying to store into the cache, but the cache already is filled. The cache already filled. So if if we specified here overflow to disk true, what is going to happen? So the required information is going to override. The required information is going to override the new So what is the information is going to get it from the DB? The new information is going to store here. The old required information is going to, we are going to lose. So that's the reason what I suggest here, the overflow to disk I specified as a false. So that if the cache memory is full, if any new data came, if any new data came, so we cannot store the data, right? For this purpose, we can go for the overflow disk. The last one is, so what is the last one here? Policy, like memory store eviction policy. So what it's contained here it is, so so the eviction, like memory stored eviction policy, if the cache is going to like full, the cache is going to full, right? So we want to delete some information from the cache, right? So he's going to see, he's going to check if the max element is reached by default, the recently which element is added into the cache, the element is going to remove, right? Other than, though, other than what is going to do is going to act as an first in first out. First in first out means when the cache is enabled, right, and is going to it with the database and is going to add some copy. This is a first input, and is reached our 500 element. Is reached our 500 element, and we want to remove some elements. We want to remove some element. Is going to check. So what is the first in first out element? So the first element is going to remove. Its first element is going to remove by the policy detection. So now, so just we are defining the how the policy we need to define. So this is then a last element is going to remove the LFU, and we can define FIFO also, first in first out. So the policy is going to specify how the element is going to removed from the cache. So that's the reason we can specify inside the policy. So we have one more one. So this is also FIFO. Like FIFO also, first in first out. And what I did, LFU, it is an last element is going to remove from the cache. So this is our policy detection. So this is the way we can define our cache so that we can able to get this some better performance, right? Now, so this is the basic configuration, right? So not only these configuration, so we can define, so being like we can define the class level caches or the method level caches, right? We have, as I said, we have some, for example, here we are trying to get an object by passing an student ID, right? So now every request for 1,000 requests, so this method is going to call. So what is the bean? Bean is nothing but a Java class. So here it is an student hibernate do MPL. So you can define the cache at the bean level or the method level. So how we can define? So we will see. So now for these, so what I'm doing here. So if you are trying to define the cache at bean level or method level, so we need to define like, EHCache proxy. So we can define EHCache proxy, and inside the proxy, right? Inside the proxy, we can define ID for what is the proxy ID, like student Leo. I'm defining a proxy ID called student Diego, and internally I'm specifying the one more cache, like EHCache and caching. EHCache caching. So now I'm defining method name. Now I'm defining. So method name. So what is the method we are getting? Like get student, right? And so we can define cache name also. We can define cache name. So what is our cache here? So what is the cache here? Some student cache. So this is the way we can define. So proxy, the proxy having the student ID of the, and internally caching is going to specify so which method and what is the name of the cache. So the method name, what is going to do here? So if any request coming through this get student method is going to copy one object to the student cache, is going to copy one object to the student cache. Student cache is nothing but, so this is one only, just we are giving a name of the for cache. So we can define as many caches we require, so we can define, right? So here, so what we did here, so caching element declared with methods. Methods is nothing but we can define as many methods we need. So the values is going to return to the cache, or as I said, the values are going to stored into the cache. And so we can define one more way, like so calling here method name. Simply I'm giving a get star. So what is going to happen if the any method is starting from get? So those methods is going to cache it and into this cache. So these also we can define, so that if any get related methods are calling, so those information are we are going storing as a cache, right? So this is the way we can define caches. So not only this, we can flush our cache. So with some period of time we can flush. So how we can use the flush related information? See, so how we can use the flushing related information? So just simply we can define EHCache colon caching. Inside the caching, so we can define EHCache colon flushing. So what is going to do? So once the method is going to execute the inside the specified cache, the object are going to flush it. Flush it is nothing but is going to delete it, right? So once so we can define the flush related, like so inside the cache, right? What I'm doing here, I'm calling EHCache flushing. So how we can define flushing, right? So this is the way we can define the flushing, and the same as a we can define method name as well as cache name. So what it's going to contain? What is going to contain? See here, I am returning save. If anything is going to call, so anything, the method name save student or save employer, save purchase orders, something is method is calling based on the save. So the data is going to flushed from the specified cache. So we can define something called before calling the method we need to flash, or after we need to call. So that's also we can define using the when tag, like we can define before or after. So these are the two properties we can use. So if you are using the before, so what is going to happen? If the method is calling, so the student cache is going to flush. Flush means the cache is going to empty. So this is the way we can define, and we can go for the after also. If the method after calling there's a method, the the cache is going to flush. So this is the way we can define our caches. So it's very important when we are developing a real-time application. So it's a simple, but if you are trying to use, if you are trying so if you are trying to run application, any real-time application, so this is the way we can define. So here we need to specify the EHCache. So simply I define here. So we will run one example. So how the cache is going to work, so that we can able to see the cache, how the caches are working. And not only this, we have some important like annotation related information also we can define. So how we can define, like we have we can define the cacheable. We have two annotations. So here only I am defining. So one is cacheable, and one more is cache flush. So these are the two annotations are available. So not only these configuration, we can define our annotations also. So cacheable is nothing but is going to provide the cache, and the cache flush means is going to remove the cache. So these are the same thing. So what we discuss here, so is going to make these two, right? If you are trying to use annotation style, you can use these two annotations, or if you are trying to use XML, so you can define. So this is the way, right? So this is our main caching concept. So now the caching concept also is completed. So and tomorrow we are seeing one important concept called so spring transaction. Before going to start the spring transaction, so we will see the basic example. We will see the basic example of the cache related information, right? So don't miss, tomorrow is very important concept.